Hi everyone. Today I'm going to discuss the second part of the paper 1-3 Pure Maths 1 Variant 3 October-November 2019. So let's start. In the last video I completed 4 questions. So in this video I'll start from question number 5. In the question 5 you already know, you can see there is a cuboid with the dimensions x centimeter, 2x centimeter, 4x centimeter. Part 1 is show that the surface area s centimeter square and the volume v centimeter cube are connected by the relation. So students, we know that the volume of cuboid is length into breadth into height. So 2x into 4x into 8x, which is 8x cubed. And the total surface area is 2 into length into breadth plus breadth into height plus height into length. So if I put the values, I will get 4x into 2x plus 2x into x plus 4x into x. So it will be like 8x square plus 2x square plus 4x square. So this will be 2 into 8 plus 2, 10, 14x square, which is 28x square. This is the total surface area of the cuboid. Now, if we look back, we know that the volume is actually 8x cube. Taking power 2 by 3 of both sides, because we can see in the answer that the volume got power 2 over 3, so we can take power 2 by 3 of both sides. So V of 2 by 3 is equal to 8x cube of 2 by 3. So V of 2 by 3, we can write 8 as 2 cube x cube power 2 by 3. So V2 by 3 is equal to 2x power 3 power 2 by 3. So I can write it as V2 by 3 is equal to 2x power 3 into 2 by 3. So this will be cancelled. So V2 by 3 is equal to 2x power 2. So V2 by 3 is equal to 4x square. So if we see in the answer, we can see 7 with V power 2 by 3. So I will multiply both sides with 7. So the 7 V2 by 3 will be 28x square. And if you see that the surface area is actually 28x square, so I'll put s instead of 28x square, so it will become 7V of 2 by 3 is equal to s, or s is equal to 7V 2 by 3. So this is shown. We have to show this. S is equal to 7V 2 by 3, s equal to 7. This is the end of part 1. So the next is part 2. The part 2 is when the volume of the cuboid is 100 centimeter cube and the surface area is increasing at a rate of 2 centimeters per square per second, find the rate of increase. Okay. The first thing which we got is volume, that is V is equal to 1000 centimeter cube. Now, the second thing is the rate of increase of area, surface area. It means ds by dt, which is 2 centimeter square per second. And what we are going to find, the rate of increase in volume, means dV by dt we are going to find. So when you see the word rate, it means divided by dt. Okay, so if I look back to the part 1, I know there was a relation S is equal to 7V 2 by 3, which I shown already shown in the part 1, so I'll use this relation again. So I'll differentiate this as with this variable v, so I'll get ds over dv, ds by dv is equal to 7 into 2 over 3 v 2 over 3 minus 1. So this will become 14 over 3, 7 2s are 14, v minus 1 over 3. So 2 by 3 minus 1 is minus 1 over 3. Okay, I'll put v is equal to 1000 centimeter cube here, because I know the value v is equal to 1000. This is in the start. So ds by dv will be 14 over 3 into 1000 minus 1 over 3, or 14 over 3, I can write this 1000 as 10 cube into minus 1 over 3. So this 3 will cancel with this. So I got 14 over 3 into 10 power minus 1, which can be written as 14 over 3 into 1 over 10, or 14 over 30, or 7 over 15. This is my ds by dv. So I have to make it half. So ds over dv is 7 over 15. Okay, now I need to find the dv by dt. So I can go like this. I can approach a couple of different methods, like this is one of those methods. So ds over dt can be written as ds by dv into dv by dt, because this dv can cancel and we can get ds by dt. So I just split up this. Okay, I know the values of ds by dt. This is 2 is equal to, I know the value of ds by dv, which is 7 over 15 into dv by dt. This thing I need to find, this one. So I'll take 7 over 15 on the other side. It will be 2 into 15 over 7 is equal to dv by dt, or dv by dt is equal to 30 by 7 centimeter cube per second. So this is our answer of part 2. Now, question number 6. Question number 6 is, a line has equation this, y is equal to 3kx minus 2k, and the curve has equation this, where k is a constant. Find the set of values of k for which the line and the curve meet at 2 distinct points. So this is very important information, 2 distinct points. So keep in mind this. So I got equation of line, which is 3kx minus 2k, and I got equation of curve, which is y is equal to x square minus kx plus 2. So I will solve these both of these equations by putting the value of y from 1 here. So my overall equation will be 3kx minus 2k is equal to x square minus kx plus 2. Okay, so take everything on the right side. 0 is equal to x square minus kx plus 2 minus 3kx minus plus 2k. Okay, so this will become x square minus kx minus 3kx minus 4kx plus 2 plus 2k is equal to 0. So here this is a quadratic equation. This is my constant term. So here a is the coefficient of x square, which is 1. b is the coefficient of x minus 4k, and c is constant 2 plus 2k. Now since both equations have two distinct roots, which is given two distinct points. Therefore, discriminant should be greater than 0. Discriminant should be greater than 0. And the discriminant is actually b square minus 4ac is greater than 0. So I'll put these values here. It will be minus 4k square minus 4 into 1 into 2 plus 2k is greater than 0. And this will be written as 16x square minus 8 minus 8k is greater than 0. Or I can rearrange it like 16x square, k square, sorry, this is k, this is k square minus 8k minus 8 greater than 0. Now I need critical values. So for critical values, I will just assume that there is equal. So for the moment I will assume there is equal. 16k square minus 8k minus 8 is equal to 0. So I'll solve it for the critical values. It will be 16k square. I can take 8 common. It will make my question a bit easier. Take 8 common. So it will be 2k square minus k minus 1 is equal to 0. Since 8 cannot be equal to 0, therefore 2k square minus k minus 1 is equal to 0. I will solve it by midterm break method. It will be like 2k square minus 2k plus k minus 1 is equal to 0, or 2k common k minus 2 plus 1 k minus 1 plus 1 common k minus 1 is equal to 0. So I'll split this. So I'll take k minus 1 common as well. So I will be left with 2k plus 1 is equal to 0. So This will give me k minus 1 is equal to 0, 2k plus 1 is equal to 0. So k is equal to 1, k is equal to minus 1 by 2. These are my two values. Now, if I draw parabola, this is 1, minus 1, this is plus 1. So this will be minus 1 by 2. So my parabola will be like this. This one. Because this is positive, x square coefficient is positive, so parabola will be a cup shape. And this is greater than 0, it means the area above the x-axis outside the parabola is our answer region. This one. This means this is our answer region and this is our answer. It means k is greater than 1 and it means k is less than minus 1 by 2. If we combine these two, the answer will be k is greater than 1, less than minus 1 by 2. So this is our answer. Okay, part 2. Part 2 is, for each of the two particular values of k, the line is tangent to the curve. Show that these two tangents meet on the x-axis. We know the equation of line, which is y is equal to 3kx minus 2k. So I'll find two values because I got two values of k. For k is equal to 1 and for k is equal to minus 1 by 2. I'll put these two values here. I will get two equations of line. 3k is equal, I'll put k1, that will be 3x minus 2. And here, if I'll put k minus 1 by 2 here, it will be y is equal to 3 into minus 1 over 2 into x minus 2 into 1 over 2. So this will be minus 3 over 2x minus 1. This is another way of that line. Now, since we need to prove that both tangents meet at x-axis, therefore at x-axis y will be 0, because at x-axis all the y's are 0, so we'll put y0 here. So it will give me 3 is equal to 3x minus 2, or 3x is equal to 2, or x is equal to 2 over 3. So this is, so it means this is value of x, this is value of y, therefore point 2 over 3, 0 satisfies this equation. So this point lies on this equation. Now, the same here at x-axis, y is equal to 0, because x-axis all the y's are 0, so I'll put y is 0 here. 0 is equal to minus 3 over 2x minus 1. So I'll take this thing on the other side. So 1, yes, this is actually plus, because there is minus 1 by 2 and the minus minus will be plus. This is plus, so this will be minus 1 is equal to minus 3 by 2x, or minus 1 multiply minus 2 by 3 is equal to x. So the x will have the value 2 by 3. So again, this is value of x, this is value of y, so this point also satisfies this equation. So these 2 points are same, both have same points, both lines have same points of intersection, and here the value of y is 0, it means this point lies on x-axis, and at point of intersection, which is 2 by 3 and 0. Since this point 2 by 3 0 lies on x-axis because its y coordinate is 0, therefore both tangent lines intersect at x-axis. This is shown because we need to show that these two tangents meet on the x-axis. This was the question 6, second part, and now question number 7. Question number 7 is show that the equation 3 cos 4 theta minus 4 sin square theta can be expressed this where x is cos square theta. Okay. So I got this equation 3 cos 4 theta plus 4 sin square theta minus 3 is equal to 0. Okay. So because I can see that the whole equation got x cos only, no sign, so I'll change this sign by the identity. I know that sin square theta plus cos square theta is equal to 1. So therefore sin square theta is equal to 1 minus cos square theta. So I'll put this here. 3 cos 4 theta plus 4 into 1 minus cos square theta minus 3 is equal to 0. So it will be 3 cos 4 theta plus 4 minus 4 cos square theta minus 3 is equal to 0, or 3 cos 4 theta minus 4 cos square theta plus 4 minus 3 is plus 1 is equal to 0. Since x is cos square x, so put cos square x, cos square theta is x here. So it will be 3x square because there is cos 4, it means cos square square minus 4x because this is plus 1 is equal to 0. This is shown. So we need to show that this can be written as 3x square minus 4x plus 1. So this is 3x square minus 4x plus 1. This is shown. Part 2. Okay, solve this equation for theta between 180 and 0. Okay. So I have to solve this equation 3 cos 4 theta plus 4 sin square theta minus 3 is equal to 0. And from the previous part, I have converted this whole equation into 3 cos 4 theta minus 4 cos square theta plus 1 is equal to 0. This is from the part 1. So this is a quadratic equation in cos. So I'll solve it by midterm break method. It will be 3 cos 4 theta minus 3 cos square theta minus cos square theta plus 1 is equal to 0. So take 3 cos square theta common. It will be cos square theta minus 1, and take 1 common here, minus 1. So cos square theta minus 1, because there is minus outside the curve, so sign will change. So again I can take cos square theta minus 1 common. This will be 3 cos square theta minus 1 is equal to 0. So cos square theta minus 1 is equal to 0. 3 cos square theta minus 1 is equal to 0. So from here I will get two equations. Cos square theta is equal to 1 and cos square theta is equal to 1 over 3. So I'll solve it first, taking square root of both sides. So it will be cos theta is equal to plus minus 1, because square root is always end up with plus minus 1. So I got two values. Cos theta is equal to plus 1. So this will give me theta is equal to cos inverse plus 1, which is 0. So I got the first value of theta. If you can check, you can check by the calculator. The second is cos theta is equal to minus 1. So theta is equal to cos inverse minus 1. This will give me theta is equal to 180. This is another value of theta. Now, from this equation, taking square root of both sides, it will be cos theta is equal to plus minus under root 1 over 3, because we are taking square root. So there are two values again. First, the cos theta is equal to plus 1 over 3 under root. Theta is equal to cos inverse 1 over 3 under root, which will give me, by the use of calculator, 54.74 degrees. And the second one is cos theta is equal to minus under root 1 over 3. So theta is equal to cos inverse minus under root 1 over 3. This will give me 125.3 degrees. So there are four values. So theta will be 0, 54.74, 125.3 and 180 degrees. So this is our answer. Okay, question number 8. Okay, question 8 is the function f is defined for x is greater than 1 by 2 and is such that f dash x is this. Find the set of values for which the f is decreasing. Since f is decreasing function, therefore f dash x will be less than 0, because this is the condition for the decreasing function. Means 3 into 2x minus 1 power 1 by 2 minus 6 is less than 0. 3 into 2x minus 1 power 1 by 2 is less than 6. Take 6 on the other side and 3 on the other side as well. So 2x minus 1 power 1 by 2 is less than 6 over 3, which is 2. 2x minus 1 power 1 by 2 is less than 2. Squaring both sides, it will become 2x minus 1 is less than 4, because this will be, square root will cancel and this will be 4. So take 1 on the other side as well. So 2x is less than 4 plus 1. 2x is less than 5. X is less than 5 over 2. Now, in the start, in the question, the value is given k is greater than 1 by 2. So k is x is greater than 1 by 2 and x is less than 5 by 2. So the range of values of x will be less than 5 over 2, greater than 1 over 2. This is our answer of part 1. Part 2 is, it is now given that f1 is minus 3. Find fx. It is given that f1 is in minus 3. We need to find fx. So since I got the function, since f dash x is equal to 3 into 2x minus 1, 1 by 2 minus 6. Therefore, by integrating both sides, I'll need to take the integration so that I can get fx. So f dash x dx is equal to 3 into 2x minus 1 power 1 by 2 dx minus 6 dx. I'll take separate integrals. So this will become fx is equal to, this will be 3 2x minus 1 power 1 by 2 plus 1 over 1 by 2 plus 1 into derivative of inner function, which is 2, minus 6x plus c. This is the constant of integral. So fx can be written as 3 into 2x minus 1 power 3 by 2 over 3 by 2 into 2 minus 6x plus c. So this 2 will cancel with this one, this 3 will cancel with this one. So fx will be 2x minus 1 power 3 by 2 minus 6x plus c. Now I need to find the value of c here. So I got f1 is minus 3, so I'll put x equal to 1 here so that I can get f1. So f1 is equal to 2 into 1 minus 1 power 3 by 2 minus 6 into 1 plus c. So f1 is actually minus 3, so I'll put minus 3 here. This 2 minus 1, 1 power 3 by 2 minus 6 plus c. So minus 3 is equal to 1 minus 6 plus c. Minus 3 is equal to 5 plus c. Minus 3 minus 5 is equal to c. So c is equal to minus 8. This is minus 5, this is plus. So c is equal to minus 2. C is equal to minus 2. So I'll put this value of c here. So my final equation will become fx is equal to 2x minus 1 power 3 by 2 minus 6x minus plus 2. This is plus 2. Plus 2. This is the answer. So this is the end of video 2. I will complete this paper in the next video, which will be the last video of this paper, the video 3. So please watch video 3 for the last portion of the video. Thank you.